everyone. Welcome to Decoding AI and Hydrology for Water Management Decisions. This is a three-part virtual series co-hosted by myself, Laura Reed, and Eliza Hale. So in this series, we are going to talk about how we use AI and how AI made its way into hydrology. We're motivated by data and environmental science and wanting to use those things to help manage real problems in the world. And so we're excited to dive in with you. Just a brief slide on who we are at Upstream Tech. We are about 30 to 35 folks that have subject matter expertise in natural sciences, as well as software engineering. And we've built tools and products to help data be useful for solving environmental challenges. We work across the world. Right now with HydroForecast, which is our streamflow forecasting product, we work in 14 countries on 5 continents. So kind of go over the 3-episode series and what we're going to be covering in each of those. Today, our main focus is to kind of break down some of the AI lingo and acronyms and really understand the differences between when someone says AI, machine learning, deep learning, and dive into that. And then in part 2, we're going to discuss the differences and similarities between machine learning and conceptual hydrologic models. And in part 3, we'll share what we've built based on understanding AI and the benefits and opportunities with using machine learning models to discuss HydroForecast, which is our streamflow forecasting service. So let's dive right in. I'm going to pass it over to Eliza to break down these acronyms.
Thanks so much, Laura. I will take us away. So if you live in the year 2023, you've probably heard the terms artificial intelligence and machine learning. We don't often talk about the relationship between the two of them. So let's dive into that and try and understand a little bit how they relate. So artificial intelligence, you can think of as the biggest umbrella term. It refers to any task where machines are doing some sort of behavior task that we deem smart. So this could be anything from a smart vacuum zooming around your floor, not hitting your furniture, to ChatGPT. Within artificial intelligence, there are many different subfields. One of those subfields is machine learning. And machine learning is any application of artificial intelligence where you have statistical models and the computers are using lots of data to train those statistical models to pick up on patterns in the data. When we go one level deeper, within machine learning, there are many different types of these statistical models. And one particularly useful and popular and powerful one is neural networks. This is a subfield of machine learning that was inspired by the structure of the human brain. You could probably guess that from the name neural network. Within neural networks, deep learning is a kind of neural network in which there are many layers. You can think of that as a complicated model, a model that is built to deal with very large amounts of data and learn very complex patterns. And lo and behold, there are even subfields within deep learning. There are different kinds of deep learning models that are good for solving particular tasks. One of those is the long short-term memory network, usually shortened to LSTM. LSTMs are particularly good at picking up patterns in time series data. So here at Upstream, where one of our goals is to predict stream flow, we use LSTMs because they are particularly suited to this problem. So let's talk a little bit more about neural networks. I mentioned that they were modeled after the structure in the human brain. So here, if you haven't taken high school biology in a while, what we have in front of us is a picture of a neuron in the human brain. And the idea here is that over on the right side, the neuron takes in information, stimuli from the rest of the brain, and then it processes that information in that yellow part, the middle part of the cell. And then on the other side, oh, I think I've mixed up my left and my right, but now on the right side of the brain where it says axon terminals, That's the output. And so the idea behind a neuron is it takes in information, it transforms that information in probably a non-linear complex way, and then there's an output on the other side. So in the 1980s, computer scientists thought, okay, this is the way that the human brain processes information. Could we build models represented on computers to process information in the same way? Let's make this a bit more concrete. With our problem, streamflow forecasting, what you would input into this neural network, a simplified model of how the human brain processes information, would be meteorological information, temperature, rain, etc. The model would process that information and then output the amount of streamflow that you might have going down your stream today. Awesome. What a great solution. However, the original form of the neural network wasn't perfect for solving all problems. It has limitations. One of those limitations is it wasn't very good at handling information that had time dependency. What do we mean by that? Let's say that you don't want to just predict streamflow today, but you want to predict streamflow today. We can call that time 0, tomorrow, time 1, and the next day, time 2. The thing is, tomorrow and the day after, the streamflow on those days depends on the streamflow today. And even more complicated than that, the streamflow tomorrow and the next day depends on the precipitation that fell last week, or if it fell as snowfall, it could be precipitation that fell months ago. And the original form of the neural network wasn't built to handle that sort of time dependency. So, what did the computer scientists do? They said, let's change the structure of the neural network and create something that we now call a recurrent neural network. The idea behind a recurrent neural network is that information is passed sort of from one time step to the next. So you can see in this illustration that now there are arrows pointing from one day to the next. The idea here is that if you're trying to predict streamflow tomorrow, you would give the model all of the meteorological inputs, temperature, precipitation, etc. But in addition to that, you would take today's neural network and pass some information to tomorrow so that the model tomorrow can remember what has happened today. It can remember things like how much snow is on the ground, the previous amount of stream flow that was flowing. And this unlocked a lot of doors. It made it so that neural networks could be really good at predicting information that had time dependencies. As I mentioned before, there are many different types of neural networks. The kind we use is a long short-term memory network, and these are specifically designed to be able to remember information over long periods of time. Like I mentioned before, when you're predicting stream flow, you often have to know things about the state of the natural system that happened a long time ago. How much snow fell a long time ago, how cold it was when that snow fell a long time ago, how warm it was last week. And so long short-term memory networks are very good at keeping information in the network for a long period of time. Let's dive into the inner workings of long short-term memory networks. I am totally kidding. This stuff is interesting, but it's beyond the scope of this course. If you are interested in the math behind long short-term memory networks, we'll link to some blog posts that do a really good job of explaining this in the notes below this, in the notes that accompany this show. So in summary, what we've talked about in this episode is an overview of the fields of artificial intelligence and machine learning. There are many different subfields, and we dove a little bit into neural networks and the particulars of recurrent neural networks and talked about how and why we use long short-term memory networks in particular. Laura, I'll pass it over to you.
All right, thanks, Eliza. And now for the quiz. Everybody pencils out. Just kidding. So next time we will move from understanding the basics of AI and all of the acronyms and terms into how machine learning and conceptual models for hydrology are similar, how they're different, and why machine learning is a particularly good tool for predicting stream flow, and much, much more. So see you then. Thanks for joining.